1, 2, 3. 1, 2, 3. Audio test.
Hi, this is CB Radio Magazine, and this is kind of a funny video because I actually shot the footage for this during COVID. I was stuck at home at the time, didn't have my best video equipment, and I had purchased an antenna from Radiowavz. I purchased the Sentinel hex beam just for something to look at, something new. I had never made a hex beam, and they already had one pre-made, so I figured, what the heck, I'll take a look at theirs and see how it is. So, bought the antenna and started putting it together. So I'm going to show you how I did that in the video. I'll be voicing it over since I didn't get good audio when I originally shot this. But this is a hex beam antenna, and I'll discuss a little bit more about why these antennas are kind of cool at the end of the video. But for right now, these are the initial parts that it came with, and I'll try and keep up with the video here describing what I'm doing on the assembly and the parts and everything. So this first piece, you'll see there's a little hub there. That's the circular piece that goes onto a little tiny mast section or pole section there. There's 3 bolts that go through, and when you're just assembling this, you just stick them through just a little bit. Eventually they'll be used to tighten it down onto your mast that you're using, but you just put it through a little bit, and then up top here you can look down inside and see your SO239 connector and your 2 wires going to your side connectors there. This is all going to be open and exposed to the weather, but because it's a very simple design, it shouldn't matter a whole lot. This set comes with 6 fiberglass poles. The poles are solid, really nicely made, and they have some strings coming off of them. And there's an extra piece of string. There are the driven element of the antenna and the reflector element there. So this is the initial assembly, and I left one pole out when I was doing this to show. But the poles go into the hub section there, and there's little holes that they fit into. So you will grab the pole and you'll stick it in, and then there's a wire or string, I guess, in this sense, that has a little S hook that comes off of it, and that goes back and hooks onto the top of your pole assembly. So here we go. We're sticking in our fiberglass rod, and down at the end you have to make sure that this little section is turned upwards, because those little hooks there are going to be used later to hold wires for your antenna. And we're going to hook our cable in and drop it because we're holding the camera, and try again and we'll get our little S hook hooked in there. So this is basically the frame of the antenna system is now fully assembled, and you can see all the individual fiberglass rods there. Now we have to connect our elements. So the driven element is going to be basically 2 pieces that are going to attach on either side of where your coax connector is. And because I'm an idiot and I decided I would take one real quick glance at the instructions, I actually attached my driven element on the wrong side. So I'm going to show you how I attach the 2 wires that are part of the driver wire system here of your driven element. So you attach these on either side, but you're looking at the wires going away from the side that has the coax feed point, which is on the opposite side from where we're standing right now. That is the direction these wires should have gone. So you connect your 2 driver wires there, and they come off, and this is your driven element. And again, this would be on the opposite side if you did it correctly, but it's the same idea. And the antenna actually worked fine, but these are your driver pieces coming off. The wires will come off, they'll go out. There'll be a little separator string, and your reflector wire is going to connect, and same thing on the other side. This one's going to come out, go over, and there's a little reflector wire insulator, basically string in between the 2 sections. This is our reflector wire, and we're going to connect it up over here. There'll be the little string that I'm talking about here, and then it's going to go all the way around the back side of the frame. So let's get our reflector wire, so you can see the connection here. So I'm going to connect my driver wire through, and you'll repeat this step on both sides. And now our driven element stops there. We've got our string, which is our insulator or separator piece between our driven element and our reflector. And now I'm going to show you the whole shabam here. So here comes our driver wire. It comes down here, and you can see our separator. And now I'm going to route our reflector wire through the antenna. Now they have these nice little S-hook kind of things on the end here, and these are neat because they allow it to hold the wire in place, but the wire can actually move freely. So if there's wind or things pulling and pushing it around, it's not creating tension on every section. It's kind of flexing a little bit. So here's our string insulator between the two sections, and this is our driven element going up. And now I'm standing in the middle of the driven element in this V, which is the center of the M shape that the driven element makes. And then the back side is all of the reflectors. Now, you'll see that there's nothing in this middle section. There's a string that goes there. Well, why do we add the string? Well, that's to create equal tension all the way around. So there's equal tension going all the way around on the wire. And that's it. It's all set up now. We'll zoom in here and you can see the center of the antenna, and you'll see the coax connector on the left side, and you'll see my two driven element wires coming out, going on the wrong side. They should be coming out the same side again. Here we go, testing. I put this into an umbrella stand, and I use just a 10-foot pole. This is at my house location, so pretty easy. I use this sometimes when testing little antennas that I'm building. And you screw in those bolts, the 3 bolts that go through that hub section. You screw them in the rest of the way onto the pole. Obviously don't want to shove the pole up too far in there, so just far enough, and then bolt those down, and it tightens on the pole. And you can see that's the direction that the antenna will be transmitting. That's the middle of the M shape of the driven element. So very lightweight antenna, very small, about 11 foot in diameter. So it's just a hexagonal shape, 11 feet. And as you shake the pole here, you can see it just kind of flexes. And this is what it does in the wind. It just kind of flexes with the wind. You can actually see the cable kind of move back and forth there through the end. And it kind of maintains its shape, which is very cool. And the coax just comes off the side. You can just run that down the pole. So you could run this with a TV rotor. You could, obviously any other heavy duty rotor would be no problem, but you could do a lightweight rotor for this. You could turn it by hand. I thought these antennas would be pretty cool for a DX expedition. You can take it someplace up high on a mountain and set it up there. Here's the image again, which I should have paid more attention to when I was putting it together, but you'll see your coax feed point and you'll see your driver wire is shown on that side. I'm not sure how much difference it makes to have it on the wrong side, but there's your reflector wire on the opposite side. And this is rated as a 5.5 dBi antenna for the gain. Kind of reminds me of using a V-Quad. I think the V-Quad had a little bit better gain, but front to back on this 20 dBs, pretty good. It actually had a pretty good rejection. I tested this out with a station south of me, who I can only talk to when I'm using beam antenna, and on the vertical I can't hear him. And with this beam, same thing, I was able to hear him and talk to him, and it did block out the stations to the north of me that were on the vertical. So neat antenna for that. Just how small it is and how easy it was to put together. Now $185, it's a little more expensive than it was when I purchased it during COVID, so it's kind of pricey. There are plenty of people that have instructions on how to build these. However, I really liked what these guys put together in this kit. It was real simple, very easy to put together. SWR was about a 1.2, I believe, around the CB band, with a little variance there, but all the way up in the free band, no problem. I actually used this all the way up into 10 meters when I was testing it, and I think it was like 2.2 up there, 2.0 somewhere in the 10 meter band. So I was able to use it all the way through, and it can handle, quite a bit of power. Legal limit, it says, is what it's rated for. So very interesting, compact, small antenna with some gain. You can actually do multiple bands on these types of antennas, which is pretty cool if you're building one. But this one from Radiowavz, yeah, I think it was fun to buy. I actually might use it like if I went camping or something. I'd just bring a pole with me on my umbrella stand and set it up and do some DXing from the top of a mountain. I think it'd be a cool antenna for that. But anyway, that's a hex beam, guys, and hopefully I explained it okay, and hopefully you enjoyed the video. Thanks for watching CB Radio Magazine.